Hi and welcome to this video. My name is Irshad Raihan at Red Hat, and today I'm joined by Luis Pabon, who is Principal Software Engineer at Red Hat, and more importantly, creator of the Heketi project. Luis, welcome.
Thank you very much, Irshad. So today we'll be talking about the Gluster FS as it provides storage for cloud applications. And I'll be giving a little presentation, kind of an overview, and then we'll also provide a small demo of how that works. Okay?
Sounds great.
Let me share my screen.
Yeah, this is one of the way cool projects, and we're super excited. Luis had a talk at Red Hat Summit and a bunch of other places, so excited to following the story and looking at the demo later on.
Yes, exactly. So one of the things that we had to find out is we had to answer a few questions from our users. One is administrators want to be able to provide their customers with methods of deploying their applications and providing easily storage for those applications. So they want this all to be a really nice central place for their customers to be able to use, and all automated. Second is they want to be able to not only provide this to the customers, this convergence of all this information, but they also want to be able to manage all these systems through one plane. For example, instead of having one cluster for their compute and one cluster for the storage, administrators are looking for a method to be able to combine everything into one single cluster where it provides compute, networking, and storage. So that's from the administrator point of view. Now let's look at the user's point of view. And what they're looking for is the ability to simply deploy their application and provide storage for the application to be able to make it run on the cloud. Now, one of the challenges that users have, specifically when they deal with infrastructure as a service, is that they have to create their virtual machines, they have to manage those virtual machines, then they have to deploy the software on them, then they have to provide the storage, format it, and so on. It's kind of a complicated process. But users want something very simple to be able to deploy, and this comes right along the containerized applications that are happening now, that technology. So users want to be able to say and describe from a simple view. Here's an example. I want to describe an application simply using, for example, in here, this example uses a YAML file where I can describe how the application is going to run, how it's going to be exposed, what storage is going to have, and all of this from a simple submission into the system, and the system takes care of deploying and managing all of these assets. And that's where users want to go. So the administrations from one point, they want simple administration of the system and the cloud infrastructure, and then the users want a simple way to deploy those applications.
Yeah, I think this is way cool. I mean, especially as you think about sort of this DevOps-centric world that we live in today, right? Where you've got to sort of appeal to both audiences. This is a great story both for developers who are basically getting hands-off storage, and for the admins who are getting this sort of hyperconvergence, better cost efficiency. So it's great news on both sides.
Yeah, exactly right. And from this example, I just want to show you a small example. In here, in this one file, we describe what's called a service. That means that the application is exposed out to the outside world. And then also in the same file, we're asking the system for some storage. Here we're asking for 100 gigs of storage, and then we describe the application itself. The application here, we have that the storage is going to be mounted in this location. This location, this is an Nginx application. This location is where it has all its application where it needs to run, the HTML file, the JavaScript, and so on. So from this one set, this one file, this one submission, we have an entire application running in a few seconds.
Very cool. I love your pointer, by the way.
Yeah. The little fire guy, yeah.
Yeah. So tell us, what's the secret sauce behind Heketi?
Yeah. So let's take a look at how we can actually accomplish this. It takes 3 technologies to be able to accomplish this. The first technology is OpenShift. So if you guys are not familiar with OpenShift, it is a Red Hat offering based on the Kubernetes container orchestration management system. And what it does is that it not only has all these services and the great things that Kubernetes brings in, like managing containers across thousands of systems, but it also brings a multi-tenancy. So you're able to share these systems. You can log into a Kubernetes-like system, and then you can then deploy your applications that are your own. It has all these security measures to make sure that your applications, you can only see them, and then somebody else can only see theirs, okay? So that's how we manage the containers in the system. Second is how we bring in storage. One of the things that we do is that we bring in GlusterFS to provide shared file storage into OpenShift. But not only do we provide that storage, we could provide it just by creating a cluster just next to the OpenShift cluster, but we don't do that. What we do instead is that we deploy GlusterFS as another application inside the same OpenShift cluster. And that is what changes everything. So now you're managing your storage as an application managed by the OpenShift system. And not only do we provide just one simple cluster of GlusterFS, but we support n number of clusters of GlusterFS. So when we think about GlusterFS and we think about storage, we always think about how many nodes can we add to create one single cluster and how much storage can we add. Where in this model, we don't talk about how much storage can we provide, because we can provide n number of storage. We can provide almost an infinite amount of storage by providing many, many GlusterFS clusters, all deployed by the OpenShift system. So this is, again, for the administrator, this is a very important change. They have both the control of all their applications, we have control of all the networking, and now we have control of all storage, all from OpenShift. And all this glue is put together by this project called Heketi, okay? And Heketi, what it is a GlusterFS volume and storage manager. It not only manages and creates volumes dynamically in Gluster. If you're familiar with the Gluster, you probably know that you have to take directories and certain nodes and you have to combine them all into creating one large volume, where Heketi does all those things for you. But not just that, but it manages all this, the underlying storage also. So what it does is that it creates the bricks for you. It has algorithms to determine what failure domains, where to create those bricks. So it will provide the highest level of reliability. And all of this is provided through a service. So if you have, today we have a command line program that communicates with that service, and we actually have just integrated just a few weeks ago the service into Kubernetes itself. And we can also have methods that if customers or the administrators are deploying this Heketi service, want to be able to integrate it into their systems, you can also have access to the API and be able to add nodes, remove nodes, add more storage, add new clusters, all simply using the Heketi service.
This is way cool, Luis, because so you mentioned, Heketi is the glue that sort of, puts it all together, makes it very seamless, especially for developers who really don't want to have to deal with, working with the storage admin to carve out storage for their application. This makes it super simple for them, especially if they're working in an OpenShift environment. So that's significant. I mean, this is something that's truly unique.
Thank you. So
just curious, before we move on to sort of deep diving into Heketi for our audience, what's the story behind the name Heketi? What does it mean?
So a good question. When I first started the project, it was one of my first projects that I was starting at Red Hat, and before that, I worked at NetApp and EMC many years. So I am from Puerto Rico, and Heketi is a Taino word. Tainos are the native people of Puerto Rico before Columbus and such, and Heketi means one. So this is my first project, so it gets the name Heketi. So maybe my second project gets the name for two in Taino.
All right. Look forward to that one. It's always cool when projects have cool backstories. Great.
Yeah, exactly. So thank you. So let's take a look at how Heketi works. And the way it works is that you provide the topology of your data center to Heketi. You register your nodes, you describe what failure domain they're going to be located in. You not only that, but you describe also what cluster that node is going to be in, and what devices, what raw devices are available for Heketi to manage for storage services. So once you have all that information stored in Heketi, you can then make a request to Heketi and say, I would like a volume. And the only thing you have to provide is what size. I want a volume of 100 gigabytes or 200 gigs or 10 or 15 gigs. But you no longer have to say, where the bricks are located, how what file systems and any of those things. That's all managed by Heketi. So what it does is that when you make a request for a volume, it has algorithms to determine and figure out the brick locations in the cluster. So as you can see here in this example, Heketi has picked a device on the first node on zone 1, but it has picked its replica on a different zone. And that is done so that we can make sure that replicas are on separate failure domains. For example, it could be a failure domain is an administrator decided value, where the administrator, when they register the topology, they say, okay, these systems share the same networking or power supply. And so that's how a failure domain is decided. So in here, we have a replica 2 system, and we have a distributed replica 2 volume in this example, in this drawing. And you can see here, Heketi has picked a few more disks and replicas. And that's how Heketi works. And not only that, but you can, again, if this cluster on the left could have been full, it would have gone to another cluster looking for available storage to satisfy that request. And as the clusters get more and more full, you can add more storage by either adding devices to nodes, you can add more nodes to clusters, or you can just add new clusters. And Heketi supports all this concurrently as new requests are coming in at the same time.
Wow, this is truly cutting edge. Like I said, there's really not anything like it that we're seeing, and it's more than cutting edge, right? I mean, this is truly enterprise grade, right? This is something that can be deployed in production, especially with some of the HA features that you were talking about, across failure domains. So this is ready to go into production.
Yeah, well, thank you.
Great. All right, I think you have a demo for us, so let's get right to it.
Yeah, so this demo is, what we'll be doing here is we'll be setting up an OpenShift cluster, and all of this is set up with Rail Atomic, and we have also deployed OpenShift 3.2 onto those systems. And what we're going to be doing is we're going to deploy GlusterFS inside this OpenShift system using OpenShift services. And then we're going to register the topology with Heketi, and then we're going to start using Heketi to be able to provide storage for applications. So let's take a look at the demo. So right here, let's take a look. Go into a different window. All right. So the very first thing we're going to do is use OpenShift to identify the nodes that are going to be using GlusterFS. The second thing we're going to do is deploy GlusterFS as a container, as an application on those systems. And as you can see here, let me just stop it right there. We just deployed GlusterFS in 3 seconds. It was that simple to deploy. And that's a huge change from deploying Gluster from other methods. And this is the magic that OpenShift and containers provide to administrators. So here we simply deployed GlusterFS, and here we're providing what's called the bootstrap Heketi process. It kind of sets everything up before the real Heketi process starts up. We then have all the process running, and now what we're going to do is we're going to register our topology with the Heketi that's running right there, the bootstrap Heketi. So what we're going to do right here is we checked out what clusters we have. We have no clusters. We're going to load our topology, saved, and we describe the entire topology We can describe one cluster or many clusters through a single JSON file. And this is just for simplicity of the CLI. The REST interface can be used directly to register your systems. But from the CLI point of view, it makes it much simpler for humans, from a user point of view, to be able to create a simple JSON file. So now we have a cluster. So now that we have the cluster, what we're going to do now in this Bootstrap Heketi is that we're going to create a GlusterFS volume to store all this metadata. So we want all this metadata to be kept safe. And right now it's not kept in a safe place. So what we're going to do is that we're going to use OpenShift services to be able to copy the data that we have from our Bootstrap Heketi into a GlusterFS volume, and then restart the Heketi real process with that volume mounted into that container. All automatically, all done by Kubernetes services and OpenShift services. So in this model, we just deployed the real Heketi now, which has that database on the GlusterFS volume. And now we can say cluster list. We have the same cluster that we had before. And now what we're going to do is we're going to create a volume. And it's as simple as just providing the size. And then we're going to ask the CLI just for a little more help to make it a little bit easier. We're going to ask it to create some persistent volume definitions that we're going to use to submit back into OpenShift. These persistent volume definitions will describe the volume, the GlusterFS volume, and how to access it to OpenShift. So here we have that the persistent volume has been registered and the volume has been created. And here we have the information showing on the persistent volume. Now, just for the demo, now you don't have to do this. What we're going to do is we're going to see and look at the actual mount point, the path of the actual GlusterFS volume. And what we're going to do just for the demo is we're going to take that volume, we're going to mount it on the client that we've been using. It's a real GlusterFS volume. We can do this. And that's once we mount it, we're going to write a little HTML information there just for the sake of the demo. We're going to describe how we feel, right? And how do we feel is we're going to say, I love GlusterFS, right? It's just a simple HTML file. We're going to write it into a root of the volume, and there it is. And now we're going to exit out just for the sake of the demo. And now that information, that file is on the volume. Okay, so now what we're going to do is, if you remember the slide that we had before where it had a single file describing our entire application, not only the application, but also the storage that it required. Here's the real application. Here we have the persistent volume claim is asking the system as a user for 100 gigabytes. You see how it doesn't define how to do it. It just says we would require for this application to have 100 gigabytes. And then we describe how we want this storage mounted in the system. So what we do now is we take the single file and we submit it into the system. And then we have OpenShift then satisfy those requests. Here we have that the claim has been bound to the persistent volume definition that we have provided before. And now what we do is that the application is now running, and we go ahead and say a curl command. So we go right to Nginx that is running a system. Nginx goes to the file system, reads the index.html file we created before, and voila, I love GlusterFS. And that's how simple it is to go from nothing, meaning just having an OpenShift system, deploy GlusterFS as an application, have it take over disks that are available on those nodes, run as a container, then have users come in and make requests to deploy their applications with storage, persistent storage requests, and have them satisfied by the system itself.
Yeah, this is, in some ways ushering in a new era, right? Where infrastructure starts to behave like an application. As simply as you would manage and provision an application inside OpenShift, you're actually, we saw it here, right? A few seconds we're talking about setting up, what would usually take, way longer. So this is truly really interesting. So Luis, what's next for Heketi?
Yeah, so what we're working on next is actually, we don't think that was fast enough. That's how we think. Instead, what we're going to do is we're going to make it even easier to deploy by using a new object and services from Kubernetes called pet sets. So we're looking into how pet sets and are going to help deploy Gluster into the infrastructure of the system of OpenShift and Kubernetes. That's one of the things we're working on right now. Second is now available, I think Kubernetes 1.4 was released just a couple of days ago. We have been working very hard at adding more support in Kubernetes to be able to communicate with Heketi, so that you saw in the demo that the administrator created the volume, but what we want instead is that the user submits the persistent volume claim, meaning I would like some storage, have the infrastructure automatically allocate that storage for the user, bind it for them, and then automatically set it up for them. All that without interference from the administrator. And that is now available since Kubernetes 1.4. The last thing we're working on is being able to work very well with Kubernetes. One of the things that we did first is we looked at OpenShift and how it deals with multi-tenancy. So one of the things that we need to do is finish our work to be able to work with Kubernetes and the methods that Kubernetes uses for authentication. And that should be done, I think, in the next week. So maybe by the time you see this, that'll be already done and released. So
okay, sounds good.
Next is,
yeah, go ahead, please.
Yeah, next is there's a lot of information out there. We have a lot of documentation available in the wiki, and we have some demos also available from Vagrant that you can set up all this yourself. And we also have an entire presentation that I gave at the Red Hat Summit available in the YouTube link right there. Thank you.
Outstanding. Luis, thanks so much. Thank you to our viewers. Also, as Luis mentioned, there's a lot more coming. We're actually going to be at the KubeCon conference in Seattle in early November. So hope to see some of you there, and hope you can join us for another video another time. Thank you.